Welcome to another session of solving problems with Elixir. In the last video, we discussed a systematic way to design functions, where specifically we discussed a recipe which had 6 steps, which allows us to tackle the problem of designing a function in small pieces. So those 6 steps were, we started with writing the signature of the function, and then the purpose, what is the function supposed to do, and then the stub, which was the scaffolding, and then some examples wrapped as tests, and then finally we write the body, and then ending up with testing and debugging. So now we are going to practice this workflow with few simple function design problems so that we kind of internalize this process, and going forward we are going to use this recipe in all of our function designs. So first problem to practice is fairly simple, and it is very common in starting computer science textbooks, which is given a temperature in degree Fahrenheit, convert that temperature into degree Celsius. So let's see how we do it. And just to get the problem started, the conversion is fairly simple, and the basic conversion is that we want temperature in C, which is equal to temperature in F minus 32 times 5 divided by 9. So if I have a temperature in Fahrenheit and I want to convert it into temperature in C, we are going to use this formula. So let's see some simple cases that eventually we are going to add into our test cases. So if my temperature in Fahrenheit is 32, I'm going to get 0C. Similarly, if the temperature in Fahrenheit is 50, I'm going to get 10C. And then if my temperature is 40, I'm going to get negative 40. So negative 40 Fahrenheit equals negative 40 degree Celsius. So with these use cases, we're going to design our function using this design recipe. And at this point, I would encourage you to pause the video and then go try on your own, since you have the recipe, and then we can come back and see, you can compare my solution with how I did it. So the problem of conversion itself is fairly simple, but it would allow you to practice, which is, I think, the most important part in learning any skill, is to do the hand motions yourself so that we build some kind of a muscle memory to internalize this process of designing functions. So anyways, at this point, I would go back to my editor, and we were already building a module called math, so I'm going to continue with that. And our first step is to write the signature of the function. So that starts with spec, and we have to think about a good function name. So I'm going to start off with F to C as my function name, and inside I'm going to say the type of argument that it's going to take. So it can take any kind of number, and then the output also would be a number. So that is my signature of the function. Then I'm going to write the purpose. So here I'm going to say compute temperature in degree C given a temperature in degree F. So here is my purpose of this function. The third step is to write the stub of the function. So we'll start with the def f2c, and again we are going to think about what should be the name of the parameter, and let's call it degree f. Right, we start the do block and then inside we'll do the body, but right now we are just writing the stub. So again I look at the signature and say it has to be a number, and I pick one of the simplest numbers, which is 0. So we finished the third step of writing the stub. Now we are going to come up with the example and wrap those as tests. So we already have written few examples, so we are going to use this table to create our tests. So for this, let's say write test and it was 32 f should give 0 c, right? That's what we want. So we're going to make an assertion that our math f2c 32 should be equal to 0. Let's write the second test where we say 50f should give 10c. So we start our do block, make an assertion that math f2c 50 should be equal to 10. And then the third test is going to be negative 40f should give negative 40c. So again we are going to make an assertion math.f2c negative 40 should give negative 40. All right, so this completes our test, and once again just to make sure our stub was correct and our tests have been written correctly syntactically, so they should not give any other error besides failing the test. So we are going to run our mixed test, and we see that 6 tests were written. 3 are from our previous exercise where we had the square function being tested, and we created 3 new functions for the f2c, and it says 2 failures. That's kind of an interesting, because we wrote 3 tests and we did not expect any tests to fail. It just so happens by chance that in the stub the output value that I chose that was equal to one of the expected values in my tests. So this was my first test case, that 32 Fahrenheit should give me 0C. But this was just purely by chance, and we have to implement the function to make sure all 3 tests pass. Going back again to our formula for conversion, we are going to use this formula to implement our function. So this is going to be degree f, right, minus 32 times 5 divided by 9. So this is the expression for our computation, is the implementation, and then the last step is going to be testing our functions again using mixed test, and all our 6 tests now pass. So this kind of covers again the entire design recipe to design a function for temperature conversion. So we went through writing the signature first with the @spec, and then writing the purpose inside @doc attribute. Then we wrote the stub where we wrote the function name but not the implementation. Then we wrote the 3 tests for our conversion specific cases, and then finally we implemented, and at the very end we tested our implementation. So that's the entire design recipe. Once again, I would encourage you to go back to your editor and try this out. Go through the recipe so that you can also internalize the workflow.